All right, well, hello everyone, and welcome back to AWS OnAir Data Dive. This is the show where we dive deep and get those data treasures for you. I'm your host, Aditya Saman, coming to you from Dallas, Texas, where it's super hot, 100 plus degrees. And it's just how it goes at this time in Texas. Speaking of hot, today we are going to talk about the hottest topic in the tech scene, which is generative AI. Now we have talked about generative AI in the past on the show, and we had the same experts to talk to you about it. But today we're going to kick it up a notch, and we are going to see how you can actually build a generative AI app that is enterprise grade. That means secure, safe, compliant, and we are going to see how to achieve that global scale. And to talk about that, I have my good friends, Jonathan Katz from our service team and Cheyenne Sanyal from our specialist SA team. So we're going to have a good time. We're going to discuss. We're going to see some demos and just have fun at it. So let's start with some intros. Jonathan, let's start with you.
So upgraded to good friends now, DJ. That's awesome. We've
Yeah.
been working on a relationship since the last time we were on here. So I'm Jonathan Katz. I'm a principal product manager on the Amazon RDS team. I'm also on the core team of the open source Postgres project, and I've been an active contributor to PG Vector for over a year now. Super stoked to talk about this. I do want to point out that until yesterday, it was hotter in New York than Texas, thanks to this recent heat wave. But we got some, super severe thunderstorms, similar to what happens in Texas, and it's night. We have a nice summer again.
Yeah, I forgot to say both of you are New Yorkers, so expect the New Yorkers hospitality here.
He's in New
Right on.
Jersey. Big
Right on.
difference.
Oh my
There's,
God,
there's
there
a
we go.
river. There's a river that separates us.
Well, technically it's just a river, so it's not too far.
Mm.
All right, well, Shan, let's hear your intro. What do you do? Tell us.
Yeah, so hi everyone. Glad to see everyone again. I'm Shayan Sanyal. I'm on the same team as Aditya, so we are partners in crime. And I'm part of the specialist team, and more specifically, the specialist solutions architecture team. And we talk to a lot of customers in our day-to-day, more specifically these days about generative AI and PG Vector, which is what this show is all about. So again, thank you all for joining, and we'll get started.
Yeah, well, welcome both of you. You are the recognized industry standard, so I'm super excited to talk to you about this. So, Jonathan, maybe we can start with you. Like I said, we are going to do a deeper dive. We're going to kick it up a notch, but maybe we can do a quick intro so that for the uninitiated and folks who are just joining, kind of get a little bit of understanding of what generative AI is now, why it's so popular right now, and more importantly, how it kind of connects the dots with traditional relational databases, which is what we're going to talk about today.
Yeah, it's a broad topic. Let's see how much you can
Yeah.
compress into a short period of time. So generative AI is this field of artificial intelligence, and machine learning, where you're basically able to create like lots of output. It could be text, images, and video from prompts or things that or input you give in. Say, like, hey, write a story about like the cat on my desk and how it endured like the New York City subway today to get to the office. And the way that we've been able to come up with these AI models that are able to perform these generative AI tasks is that they're trained on vast amounts of information. So one way to think about it is like you could train on the content of the entire internet. And typically it's like a subset of that content, and even a subset of the content of the entire internet is a lot of information. But the key is that this is publicly available information. Now, a lot of organizations have data in private databases, and it could be data that's served publicly, but the repository of data or like the collection of data is stored within these databases, kept offline off the internet. But this data can have very powerful information that can be used to drive a lot of these generative AI models. So, for example, we were talking about reInvent later in the year. And part of what you have to do at reInvent is that you have to book a flight and book a hotel to travel to the conference in Las Vegas. Now, information about flight bookings and hotels is kept within a database. And if I were to just to ask a generative AI assistant, like, how much does it cost to stay at so-and-so hotel, it'll have to look up that information inside that database. Now, there's different techniques that are used to be able to deliver that information to a customer. You could train your own foundation model. And that typically is like the best way to do it because you're going to get the most accurate responses, but it could be a very time consuming endeavor and a cost consuming endeavor as well. But there's a very efficient technique called retrieval augmented generation where you can query the data that exists in a database and attach it to the prompt that you send to the foundation model. So effectively, it's like you take the question that comes in from a user and you basically add more information that already exists in the database. And you tell the foundation model, well, hey, use that information I took out of my database to like tell Cheyenne that's gonna cost him $500 to fly to Las Vegas on that particular weekend. And that's really cool because basically you're able to use these existing foundation models, such as the ones available in Amazon Bedrock, along with the data that already exists in your database to create these enriched generative AI responses. So that's how we bridge this world of generative AI and foundation models and data that may already exist in our databases from the relational database world.
Yeah, that makes sense. I mean, just to kind of what I got from this is you have this internet scale models. How do you customize them with the database that you have? The data that you may have. I know Cheyenne is ready to break out his Hawaii story, so we'll get to you, Cheyenne, about that.
I love
Um,
Hawaii. I cannot complain, right? So,
exactly. Okay. Well, I heard you say RAG or retrieval augmented generation. I think I got that right. Okay. Well, that kind of makes sense, right? You have ton of information, but you're basically just making it specific to you. How does that fit in with something like Aurora, right, Cheyenne? So we were talking about making these applications. So you have these models, you're building these applications, and in the past, last time you were on the show, you showed us some cute puppy pictures and all of that. That's great, right? That's all fun stuff. But if you were to get a little bit serious and we want to build this thing that is secure and compliant and it's able to scale in region and cross region, all of those things that enterprises really want. how,
yep.
do, how does Aurora or the AWS or Amazon Aurora, I should say, help with that?
Yeah, so we actually we were just chatting, Aditya. So last week, the last time we met, we actually saw a pretty powerful capability by our large language models, and we'll cover like what these are, etc. But through the power of these large language models, we're actually able to do a lot of repeat and mundane and repetitive tasks much more easily, right? And a key piece that Jonathan brought up, if someone missed it, is the vector database piece, right? So we'll go through a demo today. We'll actually be putting a lot of things together in what actually makes this enterprise grade production application. And a key piece of that is the vector database or a database with vector search capabilities. And one such vector database or a relational database with vector search is Aurora Postgres. Now, in our demo, we'll step through it in much more details when Jonathan actually does the demo. But imagine we are a fictitious bookstore called Bookshop Inc. And we are probably doing really well with our online presence in the US. Now we want to expand globally, right? Imagine, just for the sake of simplicity, we are expanding in the Europe region, UK.
Yeah, not
So
not very subtle, Cheyenne. We're talking about a bookstore, your Amazon. Okay, go ahead.
I know, right? We have to. We so this is our bread and butter. What as a sales manager, what I will really require to do is imagine my bookstore information, my product catalog, my hotel information is actually stored in my existing relational database. Just imagine a Postgres. Could be anything. Now, in order to extend that, I, as a sales manager, need the capability to join that relational existing data with a similarity search query. We call this similarity search in the sense that we are specifying some keywords and we are trying to find some similar items in the catalog or in the bookstore or in the hotel to that specific keyword, right? And this does not have to be an exact match. The way these models operate is on the principles of approximate nearest neighbor search, which is a like match, right? So specify something, you don't need to know anything. Just give me a book for a self-help book, for example. So the number one ability for me is to join my existing relational data with my vector data. That's number one. Now, of course, our Postgres being a relational database, I seem to think it does the joins really nicely, right? customers
Oh, yeah.
may have a different opinion, but I really feel relational database shine in these cases. The
I would
second
agree
use
with you.
case, yeah, of course, right. So the second is, let's say we have another requirement around the global aspects of it, right? Now we are trying to expand globally, and I, as a sales manager, need my queries or my search queries to actually work not only in my single region like US, but also across UK. And by doing that, I also need something like a security, some level of guardrail, some level of security, in order to not see the list of books or the store in the UK region, which is accessed by the European sales manager. So in order to couple those things together, Postgres gives us a couple of different things. For the global aspects of it, we are actually going to use the Aurora Postgres' global database capability, and
Yep.
this feature is going to give you basically an option to span your single Aurora database across multiple regions. You can have up to 5 regions. And you basically, by doing so, what you do is you are now enabling your application to do things like high availability across regions. You are making your applications resilient to disaster recovery. You are making your applications actually serve low latency reads in a secondary region.
Yeah, that makes sense. So I guess we are basically combining the best in class in the data models or the ML models, and also on what Aurora or the traditional databases have to offer, right? So
Yeah,
you get the
exactly.
scale, you get the security, you get the high availability, all of that kind of good stuff. So speaking of what databases do really well, Tech with Raj wants to know what
Mhm.
are vector embeddings. I don't think we touched upon that, so maybe this is a good time. And how do they relate to the retrieval augmented generation that we talked about at RAG?
Absolutely. So that's a great question. And in fact, think about like the grumpy cat that Jonathan just showed, right? Think about more objects in the real world where these objects are actually not really interpreted well by the machines. We are trying to get some sort of a search query run on our bookstore. We're trying to get a price for our hotels in Vegas for maybe later reinvent this year. So, in order to kind of understand these real world tangible objects by the machine, in this case, the machine is nothing but our database, we need the database to see it in a form that it can interpret, it can translate, and sort of run those similarity search queries on, right? So, as machines, as we know that machines only understand binary, right? Zeros and ones and numbers and all that kind of gibberish. So, we need a way to convert these real life objects into these numerical representations that the machines can understand.
Right.
In our case, the Postgres database can understand. And in order to do that, we use something called as an embedding model. And within the AWS platform, we actually support a bunch of those via Amazon Bedrock. And if you're not familiar with Amazon Bedrock, it is our serverless API based service for hosting a bunch of these embedding models as well as large language models. And the task, the whole and sole purpose of these embedding models is to actually convert these real life objects, or this could be even simple text, images, videos, audios, etc., to a format that the vector database can understand. That whole process is called vectorization. And the numerical representation that gets stored in this database is called vector embeddings.
Nice, nice.
Yeah.
You talked about Bedrock, but I also hear there is something called Party Rock. What is that about?
Ooh, now we're getting into the party space, right? So,
Yeah.
all right. So, Party Rock is actually a very fun, sort of lightweight app that we built as part of the AWS teams. And it's supposed to give you a quick way to get started with a lot of these fun applications, right? So, if you see these days, generative AI is so powerful. What I use it personally is to kind of as a personal nutritionist. So it'll actually generate health recommendations. What should I eat? What should I not eat, etc. Similarly, if you want a travel planner for like vacation in Hawaii, Maui, which is coming up for me,
There
I
you
would
go. You
use
have
that.
you have to call
Right.
that out, right? We have to
Exactly.
mention Hawaii every single
So,
time.
Party Rock is basically this encapsulated world of giving you these Lego blocks of playing around. So you basically pick and choose your embedding model. You can pick and choose the prompt, You can actually tailor the prompt to something that you really wanted to sort of respond with. And all these things we'll actually look at the demo today later on. But just to understand that it's a really nice place to kind of get fun, go and have a lot of fun, start building out your applications with a drag and drop simple interface. You really don't need any coding skills. You don't need to know any programming language. It it doesn't get as simple as Party Rock, right?
Okay, so basically a Gen AI app that writes itself. I love it, love that. All right,
Yes.
so well, enough talk. We're gonna get into demos. Hopefully, Jonathan is gonna show us a great demo here. But before we do that, I just wanted to remind everyone: don't forget to take our surveys. We will remind again. We'll share a link here in the chat as well. Take the survey. The first 50 people get like $20 in credits, so you can try out all the fun stuff in your own account with this credits. So yeah, please let us know how we're doing. All right, let's look at some demos, Jonathan. What demos are we looking at today?
Well, did you? Behind door number one, we have an awesome demo today that's going to cover a lot of the things that we've discussed, which is basically building as Sharon called it, like a global application, dealing with, basically dealing with something where we have people working in the United States, people working in Europe, and they're trying to access the same data set, but they're going to be using it in a way where they can only access the information that they have. But even better, it's going to involve generative AI, and we're going to dive into that. So if we could please share the screen, we can get started with the demo. So first, I just want to mention what we're using today. We're going to be using all sorts of technologies, but the way we're going to set up the demo is using something called a Jupyter Notebook. A Jupyter Notebook is actually really awesome. It's a tool that's used in data science and also used by application developers to basically try out code, try out experiments that can ultimately get moved into production. And Amazon SageMaker has a feature where you can host a Jupyter Notebook. And what's cool is that we are going to execute code samples live today as we see how we build up our application, and then we're going to run a really fun generative AI application altogether.
Cool.
So let's dive in. So as Sharon mentioned, in our example today, we're going to have this bookstore. And in this bookstore, we're going to have salespeople in the United States and Europe who have to make decisions about books. So for example, one of the things they need to understand is how well are books selling? If a book is not selling well, they probably want to replace it, but maybe they need to first understand why it's not selling well. Is the book itself just not that great, which could be indicated by the negative reviews on the book? Or does it actually just need more marketing because customers are not aware of the book being available in the bookstore?
Yeah.
So what we're going to do today is we'll go through basically a collection of books. I think there's several million books in this bookstore, and we're going to basically use generative AI to help us sift through the reviews and understand which ones are not doing well and get a summary of them. So instead of like the seller having to read through, say, like hundreds of reviews in order to make the decision, we're going to use these foundation models to summarize them and be able to make that decision much more quickly. And that's really the power of generative AI here, is that we're able to accelerate our tasks.
Yeah, I
So
wonder, Jonathan. I mean, if you were to do something
yeah,
like this with that or pre-Gen AI, how long would it take? And you're basically going to show us here in within minutes, I'm guessing.
within minutes. Well, maybe even within seconds, but it's going to
Oh,
take us
cool.
minutes to set it all up. But yeah, it's certainly a lot longer. I can say I've done comparable tasks in my career around classifying and documenting information, and certainly being able to speed it up helps. So let's talk a little bit about the architecture today. Some of these steps, it's gonna be like a cooking show. Some of these steps, we put the turkey into the oven and the turkey's gonna come out, and we'll talk through that. But the first thing we need to do is that we need to have a data set. And in this case, we loaded a data set into an Amazon S3 bucket, S3 being a very cost-effective way to store a lot of information. We then took that data, in particular, there's certain aspects of the data that we're going to turn into those vectors, which we'll talk a little bit more about in a second. Once we have those vectors created, we store them in an Amazon Aurora database using the global DB feature. And then we use it as part of that RAG workflow. And recall that the RAG workflow is that we submit a query to the database asking for some kind of information, and we turn it into a prompt that we put into the foundation model to output an answer, in which case is going to be the summary of our books. Finally, one other piece that we're going to see today is a service called Amazon Comprehend. Comprehend does something called sentiment analysis, where it can take a bunch of text and determine, is this positive, is this negative, is this neutral? And we're going to use that feature in order to understand the context of a review that we're looking at, if it's a positive or a negative review. We're going to tie this all together in an application built using the Streamlit framework, which is going to be the capstone of our demo today.
And I remember working with Comprehend. This is all pre-Gen AI, but it's so quick and easy to use, right? All you do is basically make an API call. And I think what we're going to do here is not even that, like just run a SQL query. That's going to be fantastic.
Right? And this is cool, right? Because we could use, for me, it's kind of funny to call it traditional machine learning methods, but we're going to use traditional machine learning methods, generative AI methods, and relational databases to tie all of this together.
Yeah, that's
So,
fantastic. Can't wait.
yeah. So let's dive in a little bit into the setup. And what happens in the Jupyter Notebook is going to kind of mirror like how you would set this up within your application, which is first we need to install some dependencies. So turkey's already in the oven. We took it out. We've already done this part. And then we created some functions in order to make it easier to visualize what's going on. So, for example, if we want to be able to execute a SQL statement within our database, we're going to display some query results as well. There's going to be a point where we're going to look at the summary of a review. And again, while we're going to see this in the application itself, this gives us a way to test it before we deploy the application to production. And finally, there's a particular feature of Postgres we're going to look at later called row-level security, which is going to help us segment the information in terms of what our users in the US can see versus what our users in the EU can see. So scrolling down, the next thing we have to do is actually set up our database. And there's 3 extensions we're going to use today that make this all possible. So stepping back a second, Postgres is an open source database. It's been around for nearly 40 years. I'm actually the same age as Postgres, so go look that up. And what's fun is not only what's fun, but one of the key original design decisions about Postgres was to make it extensible. And this is a very powerful notion because being extensible means that you can add functionality to the database without having to fork it or create a new copy that ultimately needs to be repackaged or downloaded in some way. And because of this, it's possible to add new capabilities to Postgres through these extensions. One of them is vector search. PG Vector, which is the extension we're going to use today, was built entirely without having to make any modifications to Postgres. There's other extensions we're going to use today as well, including the Amazon Aurora machine learning extension, which is going to be how we interface to both Amazon Comprehend and some of our calls to Amazon Bedrock today, as well as the Amazon S3 extension, which is we used as part of our data loading process.
Yeah, it's been there forever.
Yeah. And now, my favorite part, the data model. So full disclosure, I started out as an app developer, and because of that, for me, the best part was always building the data model, and then you have to write the application logic. But I always like the data model. So this data model represents our bookstore, and there's a few key elements here. So the first is we need to be able to keep track of the information about our book. Some of the key metadata, like the title, description, the price, and the book genre. But there's a special column here called the description embeddings. And that's going to be where we store our vector data. So the description embeddings we're going to see is going to be made up of 3 components: the title, the description, and the book genre. We're going to take what happened when we generate the vector embedding. What we're going to do is we take those 3 pieces of information, concatenate them or keep them together, send them to the embedding model, and then have it come back. Because ultimately we're going to perform a vector similarity search over that. And recall that the vector basically gives us a way to compare common terms between each other. So for the example I like to give is my friend Grumpy Cat here. How do I know the difference between Grumpy Cat and water bottle? Particularly if they're images, or particularly, let's say I search for the word Grumpy Cat when I'm looking for an image of Grumpy Cat. The vector allows us to do this because using a vector, we have a common mathematical way to determine how similar these 2 objects are to each other, which in this case, these 2 things are not that similar. But if I took my water bottle and my coffee cup, likely we're going to see that they're much more similar, and we're going to get a distance score that is much lower. Now, once we have that, there's some more information we need. So recall that.
So I think there is a question. Just let me just get that real quick because it is in context of this, right? So you talked about vector storage. I think the vector storage and these search methodologies are kind of they go hand in hand. So the question here, Tech with Raj is really into it. He's asking what new features have been introduced that are going to potentially speed up this search, if there's anything like that.
Yeah, that's a great question, Tech, with Roger. We're going to get a little bit into that in the next examples. There's I'm gonna introduce it here, and then I'm gonna talk about it a little bit more later in its context. So
Cool.
typically, when you do a vector search, when you're doing something called a similarity search, you have to look over the entire data set to find your most similar neighbors, and that's called an exact nearest neighbor search. There are certain techniques that help speed that up. Like for example, in geospatial domains, you're technically looking at vectors, albeit very small vectors, 2, 3, and 4 dimensional vectors. Think about looking for things on a map. And there's techniques where you can like very rapidly zoom in on those, points. Now, with the vectors coming from these machine learning models, they can be 700 dimensions, 1500 dimensions, 3000 dimensions. And a lot of those techniques don't work for an efficient search. So that's where we get something called an approximate nearest neighbor search, where we're able to look over a subset of these vectors and be able to find search results that are highly relevant to our source vector. And there's a lot of factors that go into this. It's probably worth a deep dive topic on its own. But what we're going to see today is how we can use an approximate nearest neighbor search to be able to speed up those searches. We're also going to look how some traditional search methods can speed up those searches as well, which actually gets into the rest of our data model. Because as mentioned, like even though we're going to be searching over the books, we're interested in the sales information, the return information, see if people are returning the books, as well as the book reviews. Like, do people like the books, not like the books? And we actually are going to build out a special summary table to search over this data that's going to allow us to make a more efficient relational search. So here's all the code that allows us to create these tables. And I'm not going to go through every single line, but this basically implements the data model. And down here is where we're going to create that specialized vector index to be able to do the search over the book data. So in this particular case, we're using something called an HNSW index. That's one of the approximate nearest neighbor search algorithms out there. pgvector offers a choice of two. There's HNSW and IVF flat. HNSW tends to be a little bit more popular because it is easier to use, and you can also get some high performance, high recall queries or highly relevant search results when you use that. So next, we're going to import all the data into our database, which I'm not going to, I'm going to skip a little bit over that, but here's that key table that I mentioned earlier, which is being able to create a summary of our book item sales. So a key element of relational database design is that you try to normalize your data to avoid data duplication. But sometimes you want to be able to consolidate data into a single table for faster lookups, particularly if you have to create a sum of your data or count particular values. You can say, well, ultimately speed up search. So in this case, for our salespeople, we created a table that's going to look at book sales and reviews over the past 180 days or past 6 months, and be able to basically put all that information in a single table to make it simpler to do the lookup when we're trying to determine our underperforming books for our different salespeople. So let's make sure everything has been loaded correctly, which it looks like it has. And now you can see like the power of the Jupyter Notebook. Like I just, this ran SQL queries against the exact databases, so everything's in there. So now we can begin the demo. So the first thing we're going to do is we're going to look at that sentiment analysis with Amazon Bedrock. So I'm actually, what I did here is I actually cleared the sentiment analysis on of some of these books because we're going to see this work in real time.
Yeah.
So notice here in our data set, there's several books, well, 2 different books and a bunch of different reviews on it. And what we're going to do is we're going to call the Amazon comprehend to get that reviews, that sentiment, as well as our how confident we are in the sentiment, which is going to be a score between 0 and 100%. So we're doing this in a stored procedure in Postgres, so it executes successfully.
And we're just doing that by running SQL queries, right? We
Yeah,
don't have to learn any models, anything like that.
yeah, and we're going to look at the code in a second that does that. So let's do some spot checking on this and see how well did our query perform. So it seems like this is going to be a positive review. We're talking about master the art of, I'm guessing, characterization. So our review
Positive.
sentiment is positive, yeah, and with 98% confidence. Meanwhile, in this review, it says there's nothing really new, revolutionary, et cetera, et cetera. Seems like it's going to be a negative review. So that's pretty cool that the machine learning models are able to figure out that sentiment, and that's going to be key as we move forward and try to understand which books are underperforming in our marketplace and what we should do with them.
I don't know if it's impressive and or scary at the same time that a machine is able to basically understand a human emotion just by reading some text. That's kind of quite fantastic.
Yeah, and I think that that's the connection in our language is that there's all these patterns that we typically have that allow us to be able to perform that analysis or allow the machines to do that. And to show you how this works, this is how the store procedure worked. And right here is where we make the call to Amazon Comprehend, which, as you pointed out, Aditya, is just an SQL function. And that's really cool for a lot of reasons, because for one thing, we're able to interact with these remote machine learning models directly from SQL. So as you said, you don't need to bring in anything else, in particular to run it. And it also can help reduce the latency in some cases because you're able to do this without having to make multiple hops between different servers, which can be very important, particularly for applications that are operating at a larger scale. So now let's generate the vector embeddings. So remember, the vector embeddings are going to allow us to make these comparisons between the different objects, particularly when we start searching for books. So in this case, similar to before, here's a couple of books, and I cleared the vector embeddings on it, and now we're going to generate them.
Yeah. So just turning those objects into numbers. Fantastic.
Yeah, exactly. And again, like I can show you what the full embedding looks like. It's not going to tell you much because it's a mathematical representation. But there we go. We basically were able to do the same thing as before, where we generate the embeddings directly from an SQL call. And similar to the previous function, we were able to generate those embeddings directly from Amazon Bedrock. In this case, using the Amazon Titan embeddings model, directly from SQL. All right. So what have we done so far? So we've built up our data set. We've done the sentiment analysis for the reviews in our books, and now we've added the vector embeddings, so we're able to perform the semantic search over them that we're going to do in our application. So the next step is to understand basically how we're going to look for our information for books that are underperforming in our market. So this is really the power of SQL right here and the relational models, because we're able to take information from different sources and combine them into a single query. So the first thing is we're going to do an example where we're going to search for self-help / how-to books. And remember, we want to be able to look for that based upon the vector embeddings that are within our book info table. So first, we use this function to get the embedding for our search query, which is self-help and how-to books. And then we're going to make a call. We're going to use a SQL command to be able to look inside our information and basically find books that are in the United States that have more negative reviews than positive reviews, that have received at least 5 reviews. And we're going to order them by the books that are first match our search query, based upon what we put up here, and are basically underperforming in terms of sales. So these are the books that are not doing as well as we would like to in our bookstore. And we can see that we load it right here, and we see that okay, these are the books that are based on our search query are not doing as well as we would like. And again, that's really cool because this is the building block for what's going to be in our application. Now, the final bit we're going to cover, I'm not going to go through all of this, but as mentioned, we want to make sure that our sellers in the United States only see the information that they have access to, and our sellers in the EU only see the information that they have access to. And we can do that with a feature in Postgres called role-level security. So in this case, we created 2 roles, one for the North American users, one for the EU users, and we basically applied the permissions to the different users, across the world. And the powerful bit of this is that we are actually able to use the same database, and that's the Amazon Aurora Global Database feature. But we are able to keep one consolidated primary set of data, but we're able to appropriately segment who can have access to that data. And you can see here that we have our data distributed in a few places. Well, here's our global database cluster. And we can see that in our global database cluster, we have our instances in US West 2 for our US users, and our instances in EU Central 1 for our EU users. And again, the way we're going to see this ultimately in the demo, which is just about to come up, is we're going to have an application in the US and an application in the EU, and they're only going to be able to see the data that they have access to.
That's amazing. I mean, just right there in the console, you see a database that is literally spread across 2 continents. I mean, how cool is that? Because I remember back in the day when I was a DBA doing something like this. I don't know if it was even possible. Like you had to start from literally going out there and maybe negotiating a deal with a data center in some of these other parts of the world. So it's kind of mind blowing, at least for me.
Yeah, it's always fun to travel, at least a little bit.
I did want to touch upon a couple of things that, Jonathan, if you want to go back to the console, I think we should definitely highlight a subtle thing here, which was if you noticed the size of those clusters, the size column, there actually you see something completely different, right? Probably something that you haven't seen already. So, number one, the type of instances that we actually now support, you'll see a small D there, the R6GD large, 8x large. So those are where you're actually getting the sub-millisecond performance because of a lot of things that we have optimized on the storage side, the compute side, but more often on the compute side, right? And this is called tiered caching. Very popular feature for Postgres, especially for vector workloads. The other thing that you also see as part of the global
Optimized reads,
cluster,
right? So it's
optimized reads,
optimized reads, yeah.
exactly. The other thing that you also see is in the secondary region, in the Europe region, we actually don't have provisioned instances anymore. We are using something called serverless,
Serverless, yes.
right? So this is a sort of Aurora's offering around an on-demand auto-scaling configuration for the Postgres and MySQL databases. And what serverless means is you can scale your capacity up and down based on your application speed, right? So you don't need to worry about provisioning instances, running servers in the cloud. You can just manage your workload as required, and the database itself will do the magic of going up and down. And you actually have a mix, right? So you have provisioned in the primary region, you have serverless on the secondary region, thereby giving you the best of everything. Very
Yeah,
key
that's
point.
that's actually fantastic. I mean, it's so good to see how all of these technologies that have been built for years are coming together, right? Like just having the ability to scale in region with serverless and then scale across region with global database and then using like security features with the row level security and then the latest and the greatest like the hot topic is which is Gen AI, all of these traditional and latest like cutting edge technologies coming together. It's great to see. All right, I guess back to the demo, Jonathan.
Yeah, it was a great point by Cheyenne. Of course, cutting in right at the the when we're about to get to like the biggest part of the demo. So here's row level security in action. This is not the biggest part of the demo, by the way. The next step is. So you can see that for someone who's in the EU, this is basically showing that they don't have access to the data in North America, but someone with the data, the role to view the data in North America can see that information. So finally, let's do a test. So we wrote in our application, we're going to look for a summary of our negative reviews. So this is the step where we're taking all that information that we actually have stored in the database. So all the reviews about a particular book, sending it to a foundation model, in this case Anthropic Claude, and so give a summary of the reviews for that particular book. Now, this is the raw payload. We're going to pull this into our application so it will be more legible. But the main point of that is that this is really the highlight because this is the generative AI step. So instead of having to read through every single review, we're going to have a summary. And similarly, we're going to do this for almost the flip side, where we're also going to look for books that may be underperforming in terms of sales, but try to understand through the reviews, like what can we do to better market them. Last but not least, here's the architecture. As Cheyenne had explained, it's actually it's a heterogeneous architecture where in our North American cluster we're using provision instances. In our European cluster we're using serverless instances, based upon the workload. And again, you can mix and match based upon what makes the most sense for your workload. I keep promising a demo app, so let's demo. So in our first case, we're going to look for self-help books in North America and try to understand which ones are not performing as well as they could. So we're going to run that search. Actually,
And
and
this
at the same
this app
time,
is basically running all the code that you just showed us.
correct. It's tying
Yes,
it all
cool.
together. If you can look at if you can look here, I'm in Europe now, and I'm also going to run the same search to see what happens. So it takes a few moments because we have to query the foundation model, and here we go. We have a summary of here's some books with poor sales performance. Here is what we see in the review. So here's this book, Getting Away with It. Remember Getting Away with It from that earlier example? Well, the summary is that there's a lack of new or revolutionary ideas. It seems silly, boring, waste of time. And again, I don't know. I don't know what this book is. I can't give my own personal opinion on it. This is just the information that was fed into the database, and like from based upon the reviews, what people are saying about it. Like here's another summary that the book is for this particular book. It's like, oh, there's multiple editions. I'm confused over which one to pick. But what's nice is for me as one of the North American sellers, I'm able to make these decisions on these books, by not having to read all the reviews, but getting it quickly summarized for me. Meanwhile, in Europe, I don't have any results. Because remember what we showed in that example before? In this case, for the self-help books that are in our database, we don't actually have those. We're not selling those in Europe, so they're not available.
Yeah, that's
Now,
cool. So both versions of the app are accessing the exact same database with global database, but because of the way security is implemented using the row level security, they can only see certain pieces of it.
yeah, that's right. So now I'm going to do my favorite part. So this is actually the live demo bit where I'm going to put in a search term, in this case cookbooks, because I do like cooking. I wish I cooked more frequently, but let's see if we can find some underperforming cookbooks and understand why they're underperforming based upon their reviews. Meanwhile, in Europe, what we want to try to understand is, you probably saw me, I typed in memoir books. I'll do it again just for completeness, because our European sellers focus on trying to find books that are underperforming, but could be better. But let's try to understand, why some of these books aren't doing as well as they can, and maybe we can help market them. So in this case, we're getting a summary of this book called Inventing the Truth, and what these common themes are. Ooh, of course, I refreshed it, but the idea is that, okay, if I can understand the common themes, maybe I can build a marketing campaign around these books that will help me, speak to the audience of our bookstore to be able to sell more of these books. Meanwhile, here's some cookbooks, where we have a summary of negative reviews. So here's one where its majority of pages are blank. That could be a reason why people don't like it. And we can see that it could be selling quality because we don't have enough factual content. And this is pretty cool, right? Because again, now we don't have to like read through all these different reviews, but we're able to get the gist of why people are not buying them, why they don't like it. Perhaps an overuse of vulgarity in a cookbook may not make enough sense for why you would want to buy it, given you're looking for recipes for how to cook. So I'm very interested in understanding like what vulgarity is used in a cookbook.
But this is amazing, right? I mean, I'm guessing we can get a summary of this summary. Like if you had like millions of these books and you got these negative summaries, and if you were to summarize that and you say, well, this is what makes this type of book not perform, so let's just avoid that for whatever new publication that comes out. I keep thinking like if humans were to do this, like if we probably have to recruit so many hours to do something like this. This is amazing.
Yep. I know. I would, in fact, I'm looking at this and, some of what I have to do is review blog posts. I'm like, oh, this might be a way to help accelerate, reviewing the blog post. But yeah, so this is like really cool. Like I really like this demo example on the, that the European seller is going through, because it's giving like, it's looking at the different books and the different reviews and descriptions and coming up with themes for marketing. So again, like there's the nice thing about generative AI is that you can use your imagination and you can apply it to so many different contexts to be able to help accelerate what you're trying to accomplish.
By the way, a fun fact: if you're already on the Amazon Prime app, and the reviews that you see on the products, those summarized
Yes.
reviews, those are actually using exactly the same things behind the
I was gonna
scenes.
say I'm starting to see this a lot in even like social media content where
Oh
you
yeah,
go to like a comment section and they'll say, "Well, here's a summary of comments," which I think reading the comments is kind of the fun part.
yep.
But yeah, we're starting to see this more and more in reviews. Excellent.
I, I'm having a lot of fun reading the the negative reviews summaries. So
These are
I
hilarious.
Yeah, at this point, I'm gonna say I'm done with the demo, but like we can keep we can keep like searching for like book themes and seeing what comes up.
No, well, actually, this is a good time to maybe just step back and kind of understand, what other potential use cases might be there. Like Cheyenne, maybe you can, since you work in this quite a bit, right? So of course the summarizations, the chatbots, like that's a very common, well understood. But what do you think that where is this going? Like, what do you think is going to be a generative AI use case specifically for relational databases?
Yeah, so like we said, right, I think the whole idea about this discussion today, and we were sort of kind of leading up to it, is understand that you really don't need a brand new vector database, right? So understand that vector is just a data type. And with any database, you're actually trying to ingest and store. Basically, you're trying to enhance the application by introducing these Gen AI or vector search, similarity search queries in your database. So given the tools that you have, given the skill set that you have in your company, for relational databases, it always makes sense to kind of look at your existing tool set, look at your existing relational databases. As an example, a Postgres, we kind of did a lot of deep dive into the Postgres features. If you're already using something like a Postgres, introducing this new vector data type in the existing ecosystem kind of makes it much easier for your company, for your developers, for your builders to build on those relational applications, but now enhancing those with, let's say, a chatbot application. There are use cases where you may need to join these two together, right? So companies such as, I actually worked with a company just last week, very, very big into automotive industry, and they had a problem with they're using a relational database, and they have these troubleshooting diagnostic manuals which they don't know what to do with, and it's just sitting on a file storage system. And there's just so much information in these documents that they need a way to, one, summarize this info to kind of get to the resolution steps for a specific, let's say, a part which is broken. For that, they want to get to those specific diagnostic steps very easily, very nicely in a summarized way. Number two, imagine like if they are a call center, or if they have a help desk, right? Who is the call center agent is actually responding to calls 24/7, and they want to not have to go through this iterative life cycle of do step one, do this, replace your engine oil, step two, go and change your sort of spare tire or whatever, right? They want a way to kind of seamlessly summarize those information, give it in a self serve way to the customer. And what that will do is they will actually be now able to focus their time into much more creative things. Maybe focus on the creative parts of the organization, maybe try to do some more sort of new troubleshooting manuals, whatever that is, right? So this is where we kind of highlight the fact that if you're used to a specific database, and Amazon offers a bunch of these purpose-built databases. There's Amazon Neptune, there's Amazon MemoryDB, there's Amazon OpenSearch, there is a Postgres, and a bunch of others which actually have introduced this new vector search capabilities within the ecosystem. And this will
Yeah.
give the tools to kind of to the builders to be familiar. It's easy to scale. They already have the guardrails in place to do things like row level security, etc., and becomes much more easier to kind of learn as we go.
Yeah, so I guess what you're saying is if you have a database that already has this vector capability and Gen AI capabilities, just use it, right?
Yeah.
And that goes back to, I think our motto is to right tool for the right job. We have all of these purpose-built databases. So you have like you said, relational databases, NoSQL databases. Take your pick. If you're using something already, might as well start using that. So that makes a lot of sense. Speaking of cars and not having to go to those expensive, avoiding those expensive trips to car shops, that's always appreciated.
Yep.
So all right, so that sounds great. Jonathan, I'm wondering what's your take on the future of this? Like, where is this heading to? You do do a lot of work in open source space, and you're very active in generative AI space. Where do you
Yeah,
see this going?
yeah, no, that's I think I think we're still very early, and we like to say that Amazon, it's early days, but this technology is still early days. And I'll give an example. I actually studied machine learning in college because I thought that, this is the way things were going to go, and I ended up not pursuing it, in the same way because at the time I was like, well, I need a PhD in it, and all these models are ad hoc, and like, well, sure fooled me. It's amazing that through an API call, I mean, basically we were just making like REST API calls today, and look at like what we were able to do. Not only just determining the sentiment of some particular text, but like generating like whole like rich summaries about the information that we had. And we're just starting, and these models are going to get better, and we're going to be able to like better combine the power of these models with the data that we've already generated and the data that we will continue to generate and collect. So I think it's going to help further automate a lot of tasks that traditionally were more challenging to automate. I mean, and really is going to expand across all industries, but it's still early, so we're going to see it continue to evolve. I think the other aspect too is that it's going to change how we interface with our data. That I know there's a lot of requests for being able to, we saw everything that we saw in SQL, and there's a lot of initiative to be able to say like, hey, can you find me you know the five most underperforming books, that are self-help books that are not over the past 6 months, and have that be translated into SQL. And there's already technologies that do that, but it's going to get, it's going to make it further more accessible. Now, I agree with Andy Pavlo, by the way. Like, I don't think SQL is going anywhere. I think SQL will still be that foundational language that even if you do give a natural language query, ultimately that's how it's going to be interpreted. Like, I do strongly agree with that. But it's going to help make it easier for a lot of folks to do data analysis who may not have been able, who might not, have had like the requisite training in SQL to be able to do that. Because by the way, some of these SQL statements can get gnarly. Like I've seen
Oh
things
my
with like
God.
30 joins across,
Oh yeah.
many tables, because those are the domains, right? And some of the things we did today might be easier to wrap your head around, but there are definitely data models out there where having that natural language query, even though the natural language query might seem very straightforward, it translates to a very complicated SQL query.
Well, I mean, you used to have like ORMs, and I mean, you still do. But that sounds
Still do.
so last gen now, where you can
Right.
basically just go and ask questions to your data. That is just an amazing development. And we talk about that we're just starting out, but I also think back just a few years ago. I remember like you have to have models for everything. Like sentiment analysis has a model, and then chatbots has another model. Now you have this everything in just one stop shop. It's kind of mind blowing. And when you say things like we're just getting started, it's I'm curious to see where this goes. And
I actually wouldn't be surprised if your wife tomorrow, Aditya, comes in and let's say she books a romantic getaway and she knows about your allergies, and all of this actually is automated. So with a click of a button, I wouldn't be surprised if tomorrow I find you at Maui in Hawaii
oh my
with
god.
a nice restaurant next to the sea and enjoying your favorite meal, right? All of this could be automated.
We need to make you an official sponsor of Hawaii or something. Yeah.
I love it. I just love Hawaii.
Okay. Well, thank you both for your time. This was fantastic. I learned a ton. It's just great to see the traditional and the cutting edge getting together and just solving amazing problems for our customers. So again, if you like these type of talks, we're here every other week or every 2 weeks. And next time, we are all database geeks here. We're gonna get together and we're gonna talk about database performance tuning. So don't miss that one. And of course, don't forget to take our surveys. I'm pretty sure that's still open. Again, first 50 folks who take the surveys are going to get $20. So you can try out some of these features, make those API calls, build some fun applications, and let us know about it. Well, again, Cheyenne and Jonathan, my good friends, thank you so much for your time. This was excellent. And thank you everyone for tuning in and joining, and we will see you next time.
Sounds great. Thank you, D.